5G. We're told it's the next big thing, that it's the latest and greatest, right? Well, 5G technology comes with the promise of blazing fast data speeds accompanied by steadfast reliability and efficiency. But why should we design a data transport system with 5G technology in mind? And what advantages will we get from designing the system? Well, let's explore all the advantages 5G has to offer. So 5G boasts data transfer rates from 50 megs all the way up to 1.8 gigs a second and beyond. Speeds like that allow for implementation beyond just cell phone use. The increased bandwidth allows it to provide broadband internet to homes and businesses, for example. 5G also opens up a world of applications and autonomous solutions with its low latency, reliability, and powerful connections. However, 5G operates on higher frequency bands that don't propagate as far or pass through buildings or trees, and therefore requires more equipment. Well, all this extra equipment has to be powered. So now we need to make the system as energy efficient as possible. So let's take a look at 3 classes of cellular infrastructure supporting 5G: macrocells, small cells, and femtocells, and the advantages and requirements of each. Macrocells are large towers used for transmitting signals over kilometer distances, not unlike the traditional towers common for previous generations of cellular service. They can contain dozens of antennas arranged in an active array for beamforming and massive MIMO capabilities. Powering the antenna array and the back-end computing, which manages and switches all the data, requires significant power. By adding in additional edge computing resources in the base station, the total power can reach up to 10 kilowatts. All right, the next category is small cells, which range in power from a few hundred watts to several kilowatts. Small cells are a broad category of wireless infrastructure that provides coverage in suburban and crowded urban areas, as well as for industrial uses with dense robotic or sensor networks. They can be located on building roofs or integrated into a smart city's infrastructure. For example, a high number of small cells will be critical to support a future of completely autonomous vehicles. Autonomous vehicles will be devices on the cellular network. While on the road, vehicles will need to stay in constant communication with other autonomous vehicles and also the road infrastructure itself to provide a safe driving experience. Femtocells are the final category of network equipment we will discuss. These provide high bandwidth service to a handful of users. Femtocells will be found in offices and homes, will eventually be built directly into a building's infrastructure. They typically consume less than 100 watts and can be powered over the Ethernet. The femtocell box can be plugged into a house and could even be stored out of sight inside the walls or ceilings. And devices inside the building, such as cell phones, computers, smart appliances, and smart machines, can then wirelessly access cellular service through these boxes. And every piece of network equipment on Semiconductor has the products and solutions for high-density use cases. From MOSFETs and controllers for AC to DC conversion to point of loads, and multi-phase DC to DC for data conversion, we provide products and solutions with the best in-class energy efficiency. Hot swap, bus protection, linear power, and sensing are some of the other critical functions which are enabled by on-Semiconductor products. And no matter what 5G application you're designing for, on-Semiconductor's dedicated team of field application engineers will work with you to create the best possible solution. We're on Semiconductor. You bring the talent. We'll bring the tools. Thank you.